I was born into a world that didn't want me to ask questions. Munich, 1879. My father sold electrical equipment that rarely worked. My mother played Beethoven on a piano we couldn't afford to tune properly. The notes were always slightly wrong, slightly off, and maybe that's where it started. This feeling that something in the fabric of reality itself was out of tune, waiting for someone to hear it. I didn't speak until I was 4 years old, not because I couldn't, but because words seemed like such inadequate tools for what I was trying to understand. When I finally did speak, my first full sentence made my parents exchange worried glances. I had asked why light from the window moved differently than light from the lamp. They laughed nervously. I had noticed something they had trained themselves not to see. School was a special kind of torture, designed for minds like mine. The teachers wanted memorization, obedience, the regurgitation of facts, as if truth were something you could swallow and spit back unchanged. I wanted to know why. Why did the compass needle always point north? Why did time feel slower when I was bored and faster when I was happy? Why did everyone accept that space was just an empty container holding objects when I could feel, actually feel in my bones that it had to be more than that? They called me a dreamer, a slow learner. One teacher told my father I would never amount to anything, that I lacked the discipline for serious work. I remember walking home that day, watching my shadow stretch long in the late afternoon sun, thinking, if they can't see what I see, maybe I'm not the one who's blind. I failed my first entrance exam to the Polytechnic in Zurich. Failed. The humiliation was complete, public, undeniable. But here's what nobody tells you about failure. It clarifies. It burns away the parts of yourself you were pretending to be and leaves only what's real. I didn't fail because I was stupid. I failed because I had spent years teaching myself mathematics and physics on my own terms, following questions the curriculum hadn't thought to ask. And when they tested me on French and botany and all the proper subjects a proper student should know, I had nothing to give them. So I spent another year in a small school in Switzerland, in the mountains. And that year saved my life. I could breathe there. I could think. I could stare at the sky and let my mind wander to places where time and space weren't separate things, but woven together like threads in a fabric nobody else seemed to notice. When I finally made it into the Polytechnic, I thought I'd found my people. I hadn't. The professors taught physics like it was a completed cathedral, beautiful, finished, needing only to be admired and preserved. I kept pointing at the cracks in the foundation. What about the ether? I'd ask. What about the constancy of light speed? They'd smile condescendingly and tell me these were settled questions, that Maxwell's equations were sufficient, that Newton's laws governed the cosmos with perfect precision. But I couldn't accept it. Late at night, alone in my tiny room with candles burning low, I'd work through thought experiments that made my head ache. What if you could ride alongside a beam of light? What would you see? Would it appear frozen, like a wave somehow suspended in mid-crest? That image haunted me. It violated everything I knew about how nature worked. Nature didn't freeze. Nature flowed, which meant either my imagination was broken or the laws of physics were. I met Mileva at the Polytechnic. She was the only woman in our physics program, brilliant and fierce and unafraid of the equations that made other students nervous. We'd walk for hours talking about energy and matter and the strange behavior of light, and for the first time in my life, I didn't feel completely alone inside my own head. We fell in love the way scientists fall in love, by trying to solve the same impossible problems, by finishing each other's calculations, by lying in the grass and redesigning the universe together. When I graduated, I couldn't find work. Nobody wanted to hire the student who'd skipped lectures to pursue his own theories, who'd argued with professors, who'd earned a reputation as difficult and undisciplined. I sent out application after application, rejection after rejection. For 2 years, I barely survived, taking temporary teaching positions, tutoring rich kids who didn't care about physics, feeling my mind slowly suffocating under the weight of wasted potential. The patent office in Bern saved me, though it didn't feel like salvation at the time. 8 hours a day, 6 days a week, I evaluated other people's inventions, electromagnetic devices, improved timepieces, machines for synchronizing clocks across railway stations. Mind-numbing work. But here's the secret nobody tells you. Sometimes the cage that constrains you is also the thing that focuses your vision. All those patents about synchronizing clocks, about establishing simultaneity across distance, about the problem of coordinating time when signals travel at finite speed, they planted seeds. They made me think about time itself differently. What if time wasn't a universal river flowing at the same rate for everyone, everywhere? What if it was local, relative, dependent on motion and position? The thought was absurd. It was revolutionary. It wouldn't leave me alone. 1905. I was 26 years old, working in the patent office, married to Mileva, father to a baby boy who cried through the nights while I scribbled equations on every available surface. That year, I published 4 papers that would change physics forever, though I didn't know it at the time. I just knew I had finally found the cracks wide enough to slip through, the questions nobody else was asking. The photoelectric effect, showing that light behaved as both wave and particle, introducing the concept of the photon. Brownian motion, proving the existence of atoms through the random dance of pollen grains in water. And then the 2 papers that shattered the clockwork universe. Special relativity and the equivalence of mass and energy. E equals mc squared. 4 symbols that rewrote reality. But here's what the history books don't tell you. I was terrified I was wrong. Not just wrong, insane. The implications were too strange, too radical. Time dilation, length contraction, the impossibility of simultaneity. If you move fast enough, your clock runs slower. If you accelerate, space itself contracts. There is no universal now. Every observer carries their own time, their own truth. I'd wake up in the middle of the night, heart pounding, convinced I'd made some catastrophic error in my mathematics. I'd check the equations again and again. They held. They were beautiful. They predicted things nobody had ever imagined. That nothing could travel faster than light, that mass and energy were interchangeable, that the universe was far stranger and more flexible than anyone had dared to dream. I submitted the papers with trembling hands. Then I waited. The response was silence. Deafening, crushing silence. Months passed. The physics community barely noticed. My papers appeared in academic journals and vanished like stones dropped in a deep well. I kept working at the patent office, evaluating other people's ideas, wondering if I had wasted the best years of my mind on a theory too bizarre for anyone to take seriously. Then, slowly, a few physicists began to pay attention. Max Planck, one of the giants of the field, wrote to me. He had questions. He was intrigued. Other researchers began citing my work, testing my predictions, finding that nature actually behaved the way my equation said it should. The validation didn't arrive all at once like some Hollywood moment. It accumulated gradually, like snow gathering on a mountainside, until one day you look up and realize everything has changed.
But recognition came with a price I hadn't anticipated. I became a symbol, Einstein, the patent clerk who overthrew Newton. Einstein, the genius who saw what no one else could see. People wanted me to be a character, not a person. They wanted the quirky hair, the wrinkled clothes, the absent-minded professor who couldn't match his socks. They didn't want the man who lay awake at night terrified that his marriage was failing, that he wasn't a good father, that the deeper he went into physics, the more distant he became from human connection. Mileva and I grew apart. The partnership that had once felt electric became strained under the weight of my obsession. I told myself it was about the work, that understanding the universe mattered more than anything. The truth was simpler and more painful. I didn't know how to be a physicist and a human being. I chose physics. It's a choice I've spent the rest of my life examining. Special relativity was just the beginning. The deeper truth, the one that would consume another decade of my life, was hiding in the equations. If velocity affects time and space, what about acceleration? What about gravity? I became obsessed with a thought experiment. Imagine you're in an elevator, a closed box, accelerating upward through space. Inside that box, you'd feel pressed to the floor, exactly as if you were standing on Earth, pulled by gravity. How could you tell the difference? You couldn't, which meant acceleration and gravity had to be fundamentally equivalent, two faces of the same phenomenon. But if that was true, then gravity wasn't a force in the way Newton had imagined it, objects pulling on each other across empty space like invisible strings. Gravity had to be something else, something about the shape of space itself. I spent years chasing that insight. Years of false starts, equations that led nowhere, mathematical tools I didn't possess. I had to teach myself new forms of geometry, tensors and differential calculus that most physicists had never encountered. There were months when I thought I was close, only to discover a fundamental error that sent me back to the beginning. I fought with the mathematics like a man wrestling an angel, and it was exhausting and exhilarating and lonely beyond measure. I was teaching at universities now, giving lectures, but the real work happened in the margins of notebooks, in the hours stolen from sleep, in the single-minded pursuit of a vision I couldn't yet articulate. Matter tells space how to curve. Curved space tells matter how to move. That was the heart of it. The sun doesn't pull the earth with invisible strings. The sun bends the fabric of space-time itself, and the earth simply follows the straightest possible path through that curved geometry.
1915. After 8 years of struggle, general relativity was complete. The equations were beautiful in a way that made me weep. They were also predictions, and predictions could be tested. I calculated that starlight passing near the sun during a solar eclipse should bend by a specific amount, deflected by the sun's gravitational curvature of space-time. If the stars appeared shifted from their normal positions by exactly the angle my equations predicted, then I was right. If not, a decade of work would collapse into irrelevance. The universe would have the final word. In 1919, Arthur Eddington led an expedition to observe a solar eclipse from Principe Island. When the results came back, they matched my predictions to within the margin of error. Space-time was real. Gravity was geometry. The universe had spoken. Overnight, I became famous in a way that transcended science. Newspapers around the world ran headlines about the theory that broke Newton's laws. I was invited to lectures, ceremonies, parades. People who couldn't understand the equations treated me like a prophet. The attention was overwhelming and strange and deeply uncomfortable. I had spent my life trying to understand the universe, and now the universe of human society wanted to understand me, or rather, wanted to consume some simplified version of me that fit their need for heroes. The real me was just a man who asked questions nobody else thought to ask, who had the stubbornness to follow those questions even when they led somewhere terrifying. But heroes sell newspapers. Heroes give people hope. So I became Einstein the icon. And sometimes I barely recognized myself in the mirror. The cost of that fame was everything I had been trying to protect. My first marriage dissolved completely. My relationship with my sons became strained, distant, built on letters and occasional visits rather than the daily presence a father should provide. I remarried to my cousin, Elsa, and found a kind of stability, but it was the stability of routine rather than passion. The passion was still reserved for physics, for the next problem, the next question. I turned my attention to quantum mechanics, the strange new theory emerging from younger physicists like Bohr and Heisenberg. They were discovering that at the smallest scales, reality itself seemed probabilistic, uncertain, built on wave functions that collapsed into definite states only when observed. I hated it. God does not play dice with the universe, I famously said, and I meant it. I had spent my life revealing the elegant determinism underlying apparent chaos. The idea that fundamental reality was actually truly random felt like a betrayal of everything I had learned about nature. I spent decades fighting quantum mechanics, proposing thought experiments meant to expose its contradictions, arguing with Bohr in debates that became legendary. I was wrong. Not wrong about the mathematics. The theory made predictions that matched experiment with stunning precision. Wrong about what it meant. I was so certain that reality had to be deterministic, that the uncertainty principle had to be merely practical rather than fundamental, that I couldn't accept what the universe was trying to tell me. It's a strange thing, becoming the old establishment physicist defending classical ideas against the revolution, when I had built my career on revolution. But perhaps that's the natural cycle. The rebel becomes the authority becomes conservative, and new rebels arise to overthrow what came before. I was becoming the teachers I had rebelled against, insisting that the universe conformed to my expectations rather than listening to what it actually was. Then came 1933. Hitler rose to power in Germany. I was in the United States giving lectures when the news reached me that my property had been confiscated, my citizenship revoked, my name added to lists of enemies of the Reich. I was Jewish, which was crime enough, but I was also a symbol of Jewish physics, the relativistic thinking that the Nazis wanted to purge from German science. I couldn't go home. Not that Germany had been home for years, but still, exile is exile even when it's necessary. I settled in Princeton, at the Institute for Advanced Study, and spent the next decades trying to develop a unified field theory, a single framework that would unite gravity and electromagnetism, space-time and quantum mechanics. I never succeeded. It was the great failure of my later life, the problem I couldn't solve, the unification that kept slipping through my fingers like water. But failure teaches you things success never can. Working on unified field theory, watching the younger physicists make breakthrough after breakthrough in quantum mechanics and particle physics while I pursued my increasingly solitary path, taught me something profound about the nature of genius. It's not infinite. It's not permanent. There's a window in your life when your mind is flexible enough, rebellious enough, hungry enough to see what others can't see. And then the window closes. Not all at once, gradually. You become invested in your own ideas, protective of your own legacy, less willing to tear everything down and start fresh. I had done that twice, with special relativity, with general relativity, and perhaps that was all any human mind could manage. The young physicists were right about quantum mechanics. Reality was stranger than I had wanted to admit. But I had given them the tools to discover that strangeness, the understanding that space-time itself was dynamic, that the universe was far more flexible than anyone had imagined. Sometimes
Your legacy isn't the final answer. It's the better questions you enable others to ask.
I watched the atomic bomb fall on Hiroshima from my study in Princeton. E equals mc squared, my elegant little equation showing the equivalence of mass and energy, had become the key to unlocking the most destructive force humanity had ever created. I had written a letter to President Roosevelt urging the development of nuclear weapons before Nazi Germany could build them first. I thought I was preventing a greater evil. I was right, but I was also complicit in something that still haunts me. Physics is supposed to be pure, a search for truth, independent of human politics and violence. But truth is always used by humans, and humans are capable of both transcendence and annihilation. The same understanding that reveals the structure of stars enables the construction of bombs. I had spent my life trying to read the mind of God, as I once said, and what we found in those divine equations was power. The power to cure diseases with radiation therapy, to generate clean energy, and to incinerate cities in an instant. You can't unthink a thought. You can't unknown what has been discovered. All you can do is live with the consequences and hope that wisdom eventually catches up with knowledge. My later years were quiet. I walked to the institute most days, worked on equations that would never be published, answered letters from school children and colleagues and strangers who wanted some wisdom I wasn't sure I possessed. People ask me constantly about the secret to creativity, to genius, to seeing what others couldn't see. I never had a good answer. How do you explain that it's not about intelligence? Not really. It's about tolerance for confusion, for living inside questions without rushing to comfortable answers. It's about being willing to be wrong publicly, dramatically, and to keep going anyway. It's about loving the mystery more than the solution, because the solution is always temporary, but the mystery is infinite. The universe doesn't care about your theories, it just is, and your job is to listen closely enough to hear what it's actually saying rather than what you want it to say. I think about that boy in Munich who didn't speak until he was 4. I think about the student who failed his entrance exams. I think about the patent clerk scribbling equations during his lunch break, convinced he was either seeing something profound or losing his mind. We're all that person, in our own ways. We all have moments when we see something that doesn't fit, that challenges the accepted story. And we have to choose. Do we ignore it, smooth it over, pretend the crack isn't there? Or do we follow it, even when it leads somewhere frightening, even when everyone tells us we're wasting our time? I followed the cracks. They led me to a universe more beautiful and stranger than I could have imagined. They cost me marriages and relationships and any hope of a normal, peaceful life. I don't know if the trade was worth it. I only know it was necessary, inevitable, the only path I could have walked. The physics community has moved beyond me now. They're working on quantum field theory, on the Standard Model, on problems I barely understand. That's how it should be. Science is not a cathedral to be preserved, but a living thing that grows and changes, and sometimes devours its own parents. My relativity is now just foundation, bedrock for newer, stranger theories. In another century, someone will probably show that even space-time curvature is just an approximation of something deeper. And they'll speak of me the way I spoke of Newton, with respect for the breakthrough, but also with the clear understanding that all models are provisional. All theories are stepping stones to something more complete. This doesn't diminish what we discovered. It means we were part of a conversation larger than ourselves, a dialogue between human curiosity and cosmic reality that has been going on since the first person looked up at the stars and asked, why? I'm old now. My hair is genuinely wild, not styled for photographs, but thinned and untamed by age. My heart is weak. I declined surgery to repair an aneurysm because, as I told the doctors, I want to go when I want to go, not when medicine says I should. I've lived enough. I've seen enough. The equations don't need me anymore. They exist independent of their discoverer, true whether I'm here or not. And that's the most beautiful thing about mathematics. It transcends us. I am temporary. The curvature of space-time is eternal. I found something real, and it will outlive me by billions of years until the last stars burn out and the universe itself grows cold and dark. That's enough. That's more than enough.
If I could speak to that boy who didn't talk until he was 4, I'd tell him, your questions are not wrong. The world is wrong for trying to make you stop asking them. The compass needle points north because the Earth is a giant magnet, yes, but also because magnetic fields are the rotation of electric fields through space-time, which curves around massive objects. And following that thread will take you to the center of everything. Keep pulling, keep questioning. The people who mock you are afraid of the same confusion you're walking straight into. They're not stronger for avoiding it. You're not weaker for seeking it. And one day, very late at night in a patent office in Bern, you'll write an equation so simple and so profound that it will echo across a century. And you'll realize that your weirdness was not a flaw, but the necessary condition for seeing clearly. They'll remember the hair and the tongue photo and the famous equations, but they won't remember the nights I cried from intellectual exhaustion, or the mornings I woke up having dreamed the solution to a problem that had haunted me for months. They won't remember Mileva solving equations beside me, or the sound of my violin playing Bach badly in the evenings when the physics wouldn't resolve. They won't remember that I was a person, flawed and frightened and brilliant and broken, doing the best I could with a mind that wouldn't stop asking dangerous questions. That's fine. What matters isn't the person, but the questions. Not the genius, but the willingness to follow curiosity even when it leads you somewhere everyone says is impossible. The universe doesn't reveal itself to those who demand answers. It whispers its secrets to those brave enough to sit in the darkness and listen.